welcome back to the second lecture of week 5, in which I am discussing big data analytics life cycle. When we talk about the life cycle, the overview of the life cycle will be given first in this lecture. Then I will give you 6 phases of the life cycle that is devised from a study. The life cycle, when we say life cycle, is a starting to the end of any product. We call it cradle to grave. Now here it is a process, big data analytics process. When I say life cycle, the first part would be discovery. We need to discover what is the data set, what are we going to do. Then slowly we start preparing the model, we select the model, we start preparing the model, we put the data in the model, finally we try to validate that, and this keeps on going in an iterative way. So we will put that as a cyclic process, the life cycle. Before that, the overview of what kinds of the approaches do we have to have the data analytics. There are certain methods such as scientific method. Scientific method is a general data science where we have the descriptive, predictive, prescriptive analytics. We use tools such as which are commonly available, the tools like MATLAB which are available, or we use R programming to just have mean, median or so. We try to have forecasting tools, we try to have moving average, or we try to have the exponential forecast, etc. So these are the general scientific methods which is there for many, I would say, decades it is being used, or maybe for the centuries it is being used. We first define the hypothesis here. Hypotheses, what are these? I will come to the hypothesis and define them. Hypothesis is a statement that we say if it is not true, the data would be presenting some other result. So we define a null hypothesis, then we say that okay, this is, if the statement is not true, then the data is giving some result. So we will come to that point. Other than the scientific methods, we have nowadays methods such as CRISP-DM. So which is useful in providing input on the ways we frame the analytics problem. So this is a popular approach for data mining. Then we have Delta. So this framework gives us an approach for the big data analytics projects in which the organization skills, data sets, leadership agreement, everything becomes part of it. AIE is the approach that is majorly used by the softwares which are quite common. For example, the Tableau, it uses these types of the data sets, or it connects to it. So in this, the framework measures the intangibles and provide guidance on developing the decision models. These are only a few which I have mentioned here. There are multiple other approaches towards the big data analytics. It depends upon the kind of the data that we have, kind of the database. Database could be available in the various forms. For example, we could have, I would say, hierarchical data. Hierarchical database. Hierarchical database means it is a hierarchy. For instance, in IIT Kanpur we have director. With the director they are connected faculties, students in academics. Then he has a registrar. Registrar takes care about the administration. So this becomes a hierarchy. In the faculties we have professor, first professor HG grade, then professor, then we have associate and assistant professors. Then in students we have the PhD students, PG students, master students and undergraduate students. Undergraduate students also we have the branch wise students are there, the different departments are there. But this is how the hierarchy goes. Another kind of the database could be network based database. Network databases. In network databases we have the director, the department, the administration, and the students have also made clubs in which the inter-department communication takes place. Students have a robotics club, they have a programming club in which the people or the students from, or the professors as well from the electrical, computer science, mechanical department collectively work together. So this makes a network now. Now another kind of the database I am quickly going it through is the general people who are from computer background or who have learned the object oriented programming, they would more appreciate. It is object oriented database. In this kind of database, we have the information about a person. For example, there is a person. The person could be a student, let me say. When I say person, it would be the information here would be name of the person, the phone number, the email, right? This is one object. Now this object, for example, if it is a student, the student's year, its course, it becomes another object. Then we have a person could also be a professor. Professor, here the professor's data might be its salary or its qualifications or so. This is object oriented database. Further, we have another type, I could say relational databases. Relational database is the most detailed database in a way. So these database lead in the production line along with the management systems. So in this kind of the database, each piece of information has relationship each other piece of information. For instance, if I say roll number of the student, marks of the students, average marks of the students, so these marks of the students related to the another class's mark. So what is the average marks of other class? The word, the key becomes average. Average marks in class 1 and class 2, average marks in branch 1 and branch 2. So there are certain relationships. What is the key of the relationship? What is the intersection point? That is only to be defined. So this helps us in the data normalization as well. Next comes the NoSQL databases. NoSQL, when I say it comes to the non-SQL or non-relation databases. So NoSQL database provides us a mechanism for the storage or retrieval of the data. This data is modeled in means other than tabular relations used in relational databases. So NoSQL database includes simplicity in design. It is simpler horizontal scaling of the cluster of the machines or the systems or the people. So this kind of data structure has certain advantages. For example, it can work in a NoSQL databases such as we can work in Cassandra, we can work in the NoSQL systems which require this kind of the data. But disadvantages would be it is an open source database, the GUI is not directly available, and the backup is a weak because some NoSQL databases cannot be stored for a longer time or cannot be stored very securely unless we have our own system built for it. So the document size is large. So depending upon the different kinds of the databases, I'll keep on putting different examples from here, and I'll be talking about these in my data analytics life cycle. So in the life cycle, if I define the phases, I would put them into a cyclic view which can interact with each other. The first phase will interact with the second phase, could go to the third phase, but yes, reverse communication could also happen whenever some data point is required. For example, in the model execution stage itself, something is required, okay, discovery stage required this thing or this data point was also required, so it might come back there. So let us say my first phase is discovery. The discovery phase is the starting phase. Discovery is nothing but we are trying to explore, we are trying to only say that what is the business domain, what is the relevant history. Here we say what is business domain. Right, then we say relevant history of the data. Then have we attempted similar projects in past? For instance, Walmart first took the attempt to have the historical data and took the instances from there to forecast what will be sales in the next Halloween, what will be sales forecast in the next Christmas or so. They had thousands of the stores, so where at which point locally what is happening, which event is happening, at what shelf, what amount of the things could be stored in the history. So they pick it from there. So discovery means what is the history that we have, and what is the experience of the people, experience of the team already here. When I say experience, that is in history, have we taken similar attempts in the past or not, right? This all is taken in the terms of, do we have people who have taken these things in business domain in relevant history, or do we have experienced people already, or do we have a technology that is to collect the data, to collect what is there on the shelf? Do we have systems like, do we have QR codes already instituted? Do we have RFID badges or so? So what kind of technology do you have? And do we have the time, or what time frame are we trying to fix, or what kind of data do we need to have, what kind of databases do we have? So this is the first phase. I'll talk about this phase in detail. I'll talk about the sub phases or steps in this phase itself. For instance, in the discovery phase, we first need to understand what is the business domain, then we need to understand what are the tools or resources that we have, then we frame the problem. The problem is also framed in this very first phase itself. Then we identify the key people there, key stakeholders. Do we need to have really the business data analyst or business intelligence analyst in the discovery phase itself, or do we only need the data scientist only? That is also decided in the discovery phase itself. So then we have a meeting with the project sponsor. Project sponsor meeting means what is the overall viewpoint of the sponsor, why the person is funding us, what are the results that he or she expects. So this is also taken in the discovery phase itself. The discovery phase in the big data analytics is one of the most detailed phases where we try to get as much of information as we can, because we do not do like the other data analytics, the traditional data analytics system. We do not work upon the specifics, we work upon the detailed analysis. That is why it is called big data. And this big data, using the normalization or using the small data retrieval systems and the small languages that we have, we will try to organize that, structure that, and go to the next phase. Next phase now what I have is data preparation. So data preparation means, do I really have good amount of the data, do I really have good amount of the, or good quality of the data to start building the model? So here discovery phase interacts with the data preparation phase, in which we prepare the analytics sandbox. Sandbox, if you understand, it is generally the kids have a wooden box which might be 2 meters by 2 meter or 1 meter by 1 meter. We have small tools there, kids come and stay there so that the sand doesn't spread in your house or in your garden. We put the sand within that box and kids start playing in it. When the children are playing in the sandbox itself, they are given different tools, they can build houses, they are given different shawls or so to use the sand. So this is the kind of an analytics sandbox. Analytics sandbox means my system boundary. My system is this boundary. We will collect this amount of the data and we'll define an algorithm. In the algorithm, we'll use tools A, B, C. We'll use only SQL system to retrieve the data or delete or add. We'll have PHP. We'll connect it to some markup language like HTML or so. We'll have a web, or we'll have a website developed out of it. So this is my framework. Or I use some systems like, for a large data set, Hadoop or so that I can develop a bigger sandbox. This sandbox is once decided, we can expand or contract it in the later stages as well. But once we define it, we will try to create an algorithm which is well tested, trained and validated, so that when this is projected upon the future or the more data sets, it gives us the transformational results. So analytics sandbox is prepared here. So here is what we do is, generally it is ELT, which is extract, load and transform, or we also do ETL, that is extract, transform and load. Combining these two together, that is what I mentioned in the previous lecture as well, we do ETL. ELT, stack transform, load transform. That is, the ELT and ETL are sometimes abbreviated as this. The data is transformed into the ETLT process to make sure that the team can work with and analyze it. In this phase, the team also needs to be familiar itself with the data thoroughly and take steps into the condition of the data. So here comes the next phase, that is model planning. Once the sandbox is prepared, we plan the model. Right, this is my phase 3. Now phase 2 interacts with the phase 3, in which we determine the methods, techniques and workflow. Methods, techniques and workflow. Right. So this is made to follow the subsequent model building phase. Now here the team gets aware of the data to learn about the relationship between the variables of the data. So they subsequently select the key variables or the most suitable models out of it. So what is this? We'll take an example and we'll be more explaining. So phase 4 would be model building. As I said, because we are building the model, we need to have different data sets. For instance, if I have 20 GB of the data, the 80% of the data is generally taken for the regular testing, for the experimentation, the design of experiments in designed in such a way. 80% of data is used, 20% remaining could be used for the testing and validation. Training is, first we try to do small test, initial test or the pilot test, so that we see that our algorithm is running to small extent. When we actually try to do the test, the 80% of the data is for testing, then we do the validation. So for training, then is testing and validation. Validating. So all these steps are designed or thought of or planned in the model building stage. So in addition to this, the team builds and executes models based upon the work done in the model planning phase. So what was planned in phase 3, that is executed here. So they also consider whether the existing tools are working well or not. So phase 3 interacts with the phase 4. So if the team says that models which we have planned in the phase 3 is not working great in the training phase itself, it is identified, then reverse interaction also takes place. I'll put that with the green color. Right. So reverse interaction, if the model planning itself says the data preparation in which we have created the data, in which we have developed the sandbox, it is to be expanded more, then a reverse interaction again also plays place. If in the data preparation itself it says in the discovery phase itself we found that the people who are there, we need a more trained people who would have the specific kind of the skill sets, maybe the person who should be more aware about the Apache Spark program. So then we need more people here. Then the time frame which is set for this project needs to have 10% more advancement in it. Then we need to have time here, the data sets are more required. Then also we have the reverse interaction. But as far as possible, the reverse interaction should be avoided. So this is what I wanted to mention in the previous model itself. I would like to connect it to the previous slide here. So these two systems I told you in the previous lecture, the data analytics systems, this system might have taken, I would say, 20 days, and if I say the amount spent on this is, let me say 10 lakhs of rupees, right. So this big data analytics, the system, because it is using the ETL in a more systematic way, and we are also using the more sophisticated programs here, it would take the time in hours only. Let me say it has taken only 30 hours. And if the time is less, though the investment in the times of the people who are working on it, investment in times of if we have purchased small softwares, that will be higher, but overall expense for this would be quite less, let me say 2 lakhs. This is the speed. So that is why, though the velocity of the data is high, but we still get systems in time. So that is why the interaction or the reverse interaction between the phases is avoided or should not be there as far as possible, but yes, it is made open, it is let open, so that if it is required, we should be able to get information from the previous phases as well. So that is why any data or any data set that is not used, that is not taken to the further phases, is still stored. So that is now the advantage that we have gotten, that we have Dr. Deepu Philip also discussed. Now space is no problem at all. We can have data on the cloud, we can have data on the this small size of the pen drive, the small size of the SSD drives, in which big terabytes of the data could be stored and kept for the future use. So after model building, we need to communicate the results. This is my phase 5. We communicate the results, the major stakeholders, the different roles or different team, the people that we have discussed in the previous lecture, the data engineer reports to the database administrator, which further reports to the business intelligence analyst. The project manager can have an overall overview of the system. The sponsor is given the executive summary all the time. Business user is giving the feedback. So this is how we try to get the results. So we identify the key findings from the system. The key findings, we saw how the project is successful, and with success I will also put failure, because it is a general rule, failure is NO. NO is new opportunity. Why the system has failed, if this is also learned, we can try to not to do the similar mistake in the further models that we develop. So why the system has failed or why the part of the system is failed, that also is noted here. So the key findings to quantify the business value or to develop a narrative to summarize or to convey findings to the stakeholders, it is important here. Next comes the last phase, when we operationalize. The word operationalize means giving the final reports. It is phase 6. So phase 4 helps us to communicate the results within the system, within the stakeholders. The stakeholders now try to operationalize the system so that they can give the results to the final executives. So we deliver final reports here, that is we try to, I would say, draft the final reports, or we try to get the final code or algorithm ready, and we also prepare the technical documents. Right? So this is how it works. Here also reverse interaction might also takes place. When we communicate the results, the reverse model building testing could also happen. Once the results are communicated and they are operationalized, then there are very less chances. I will only put a very dotted line here. So it is very rare chance that one, it is operationalized, because we have gone back and forth between phase 1 and phase 2, between phase 2 and 3, 3 and 4, and so we are going back and forth to make sure that till the phase 5 we are quite sure and the system is almost perfect to communicate the results. Once the results are communicated, then we operationalize. While we have operationalized and presented the executive summary to the people to execute that finally in the market, then coming back is completely forbidden. I say it completely forbidden, but yes, there could be 0.01% of the chances that results, if it fails further as well, still after so much of the testing, something is missed or something is overdone, the systems might have to retake the overall call. So I have only put a dotted line here. Here also operationalized system could only give a feedback to the discovery. So this is broadly the life cycle phases of the big data analytics. Now I will try to discuss each phase in detail, and then we will take a case study to understand how one of the companies use this kind of the phases for actual big data analytics report making for themselves. The first phase here is the discovery phase. The discovery phase further has certain steps, or I would say sub phases in it. Let me try to collate that. Phase 1 is discovery. Right. So in the discovery phase, the big data analytics teams now have to learn or investigate the problem, develop what is the context, what are we trying to target, are we gonna improve the sales of the system, or are we just gonna improve the productivity or throughput in my factory or in my system, or are we gonna reduce the queue length in a retail shop, or are we gonna do some in additive manufacturing, the quality has to be risen high. So it depends upon what is the overall context, what are we trying to target to. Those hypotheses would be designed here, those hypothesis statements could be made, and then we go to the next phase and try to prepare the data for that. In the discovery phase, the first and the foremost requirement here is understanding the business domain. What business we are trying to target to. So data scientists generally have a deep computational or quantitative knowledge, or they have advanced degree in applied mathematics or statistics. So and the business intelligence analysts or data engineers sometimes could be a person with a PhD or so. So the team with these kind of people need to understand how much business or how much domain knowledge data scientists need to have to model the system further. So to understand the system, to have the business domain understanding, what kind of skill set should we have, what kind of the assessment a team should have, there should be right knowledge between the expertise that the team has and the technical knowledge, right. Once they have understood the system, they have to now collect the tools or resources. When I say tools and resources, now the team needs to assess the resources available to support the project. The resources might include the tools. I would just jot it down here. It should have what are the tools. So what are the systems in my company, or what technology do we have, and what people do we have who would be stakeholders or the key stakeholders in the system. So using this system, they try to, number A, evaluate the sophistication of the system required. Because when we are talking about the tools and resources, are we going to use this algorithm or this program that we are developing for the present problem statement only, or we are going to use this further for the overall, for the next 10 years, for the next 5 years, right. So to evaluate, after evaluation or when we are evaluating it, we also identify the gaps. Identify the gaps in the data sets, in the tech tools, in the skills. So whatever those are, those gaps are to be filled. So the what kind of skills and roles are needed, does the requisite level expertise exist in the organization today or not. So when we answer these questions, it will overall affect or influence the techniques that the team selects and the kind of implementation the team chooses to pursue in the subsequent phases of total data analytics life cycle. So it is advisable to take inventory of all types of the data. When I say inventory of the data, when we saw resources, we have the secondary data first. So first it is only approached upon the catalogs, the historical data, or whatever we have in inventory. If it is not available, we can also approach for the primary data. The team must determine whether it must collect the additional data, purchase it from outside, or transform the existing data. So it could be just collect secondary or primary, then purchase the data, or they transform the existing data. Transformation would need time, but it would have only your own skills. For instance, if we need to have the average sales which has happened in the last maybe in the pre-COVID period itself, what was the scenario, and post-COVID what is the scenario of the sales of the specific item, let me say the face mask itself. So if the data is available in the countries in your own area, that is fine. Otherwise we can get data from the places where the COVID most affected. Right? For instance, we can get data from China, we can data from India, the US can focus the data from India itself, we can purchase the data sets from India, or it can also transform the data that they have gotten from their country itself. It would take some time. Purchasing needs more money, I would put dollar. This needs more time, I would put seconds. Right? Data collection, if it is available in the secondary form, that could be collected directly from there. So there should be right mix of the domain experts, customers, analytical talent, project management. So this is what team is there, in the people that is there, in the tools we have discussed already, in the systems. Systems means what is the sandbox that you have built, what total size, total time that you have planned for, and what technology are you using. Tools and technology, when we talk about, then we need to negotiate for the resources at the outset of the project. So it is generally more useful to scope the goals or objectives and feasibility in the beginning itself, so the technology is selected in that way itself. Now next comes the framing of the problem. So I will call it problem formulation. Problem formulation means we try to state the analytical problem that is to be solved. Right? So what problem is big data trying to solve? For instance, in Walmart there were millions of people every day who were purchasing. So having right product at right place in right time. So this was the problem statement. So there are millions of products as well. So what products are more focused? So there was one instance that is reported in one of the studies I was reading, that the sales of the one product which was thought to be set to peak was not even there. Like the product didn't even sell in that period of 1 or 2 days. So then they identified that there was something that happened, that the rack where it was to be shelved was covered with the display of that product, and at the back the product was not even shelved. So if the product is not even shelved, the customer won't find it there and customer won't take the product home anyway. So these kinds of these small problems, small errors could come. So problem formulation means we frame the problem. So in case of retailing, this is like this, that what target are we have, or for instance as I took the example of maybe Amazon Web Services or Netflix. So there the problem statement that is to be solved could be, so what is going to come next to the box office? That could be the problem formulation. Do we need to have a serial with more emotional domains, or do we need to have a beautiful actress in that? Or for example, in comedy serials they identified using the big data analytics only that with the comedy serials or comedy movies where the animals or the animated characters talk, that is more sold. For example, the movies like Toy Story, like Toy Story, the toys itself talk to each other. So those kind of comedy systems were more sold, and this was also taken from the data that what people like more, what kind of things, or what kind of small, when we have small short movies to 3 minutes or 5 minutes, those advertisements are first set. When the likes of that advertisements or views of that rise to maybe millions or so, it is identified that okay, this movie is more expected. But what is actually gonna hit and what is gonna fail, there is no prediction of that, but we are still coming closer using right problem formulation. So problem formulation depends upon the kind of systems that we have. Again, if I take an example of maybe a manufacturing concern, so like the companies like Shell, so which is a oil extraction company, so they had a problem in the face of growing population and large requirement of the non-renewable sources still. So what attempts should be made to generate more energy from the renewable or alternative sources of energy? So this is vast energy that is wasted from the non-renewable sources, that is oil, gas and coal, that they are extracting only. So how is this affected by international politics? What are the international policies, or what is the difficulty in the exploration, or what is the hydrocarbons which are generated out of it? So hydrocarbons generated versus the renewable sources of energy, the amount of hydrocarbons generated in the non-renewable sources of energy, or using the renewable sources of energy and setting up a system for that. Setting up a system for that would include or require the investment of a lot of the money, or if suppose we are using the hydrocarbons, how is it affected? So this trade-off, that is sustainability, green, ecology balance, these kind of problem formulations could be formed, and Shell has actually used this kind of the system, the big data set system that I will come as a case study to formulate their problem. So problem formulation broadly is framing of the problem, that is stating the problem statement, that is stating the analytic problem to be solved. Let's say state the analytical problem to be solved. Generally this is problem statement. So with all the key stakeholders, each member may have a different opinion or different viewpoint of what is the problem statement. Data scientist might only be thinking of what kind of programs, how would I write this program. Business analyst is talking about how the business would run. Sponsor is thinking about the market. But still, taking an opinion or taking an input from all of them, the problem statement is made. Who makes this statement? Generally, business intelligence analyst along with the project manager states the problem. Business intelligence analyst understand what database is, how the system is there. Project manager knows what is the time frame, what are the milestones, and what is the funding that is coming. So that is stated here. So in this statement, there are majorly three major key points. Number one, identify the main objectives of the project. If I say reducing hydrocarbons, it is a broad hypothesis, like I call it first hypothesis or initial hypothesis. It might have to be divided into multiple hypotheses. Reducing hydrocarbons emission by controlling the pollution, reducing hydrocarbon pollution while having the green energy generated at the source, or reducing hydrocarbons while using the green energy in the factories where we try to build the machines. So it depends upon the small sub hypotheses that are being built here. So main objective is to reduce hydrocarbons. That is the first hypothesis that we develop. We will state hypothesis based upon this, but this is first point that is here. Then we identify what needs to be achieved in the business terms. What is to be achieved in business terms, right? Then we say what is to be done, what is to be done to meet this need. Right now I am only talking about the business viewpoint only, what is to be done to meet this need. Here comes the lower level of the business analytics, or lower level of the big data team, that is data scientists, data engineer, the people who are actually working upon this, who will be actually writing the program. So they all work upon that. A database administrator also has to give what data sets are required. So they work upon this third step. So we try to make the boundary of the system. Problem formulation itself, we have identified we have made a sandbox. Now to fix the size of that sandbox, we will say what is good enough. because we are gonna work upon the hydrocarbon saving in Shell company that we're targeted to. So are they gonna work for the overall their sales in the world, or first they are gonna talk about only the sales in US, or they are gonna talk about their sales in the US, maybe in Minnesota itself. So the problem statement, what is good enough, I'll put good enough in quotes. So that is always defined here. What is my boundary? Because the system is big, systems of the systems also becomes bigger. So sandbox in itself is a system of the systems. So this system of the systems also has to have the outer boundaries. So what are these? These are to be defined here. So that is here we formulate the problem. So it is almost taking the best case scenario approach, assuming that everything will proceed as planned. So that is how the problem is formulated. So it is almost impossible to plan everything that will emerge in the project, but definitely we can state something that is quite based upon the experience. So understanding when it is best to stop trying, this is also important, because if the failures those happen, if it happens once, it can be a chance. If it happens two, it can be again a chance. If it happens three times, the failure happens three times, it becomes a pattern. That means it has to be stopped. So that is where do we stop, where do we fail, that is also here in the problem formulation. So that is to be thought of. If we fail, what is the failure criteria? If we fail three times, we will stop it there. So then we also avoid the unproductive effort and remain aligned to the project sponsors. If it fails, we try to get back to the new problem statement or the modified problem statement. The fourth step here is we select the key stakeholders. The key stakeholders and what are their interest in the project. Here business user is definitely part of it. Other than that, the key stakeholders, so what is the success criteria, because it might be different from different people. Overall for the business sponsor, it is the money is paying back or money is coming back in the specific time limit. So this is the payback criteria or the net worth value that it has. So that is the business criteria or success criteria for the business sponsor. But for the data scientist, what is the success criteria? So that is why we need to select the key stakeholders. Do the coding or the program that the data scientist is making, does he or she has to be part of the major or key stakeholders or not? Sometimes they are told to make the program and they just follow what the database administrator or the project program manager tells them, right? So success criteria is made based upon what do we need exactly. So that is why the people who are interested in that, so those are taken. Yes, but there might be some risks. We will also need to put key risks here. For instance, like in the COVID era, IIT Kanpur medtech facility developed oxygen concentrators of their own, which were distributed to the country using a startup company. It was developed and distributed. To manufacture the oxygen concentrator within the facility with the minimum available amount of resources, the key risks which were there, the risk analysis, the risk priority number was set. So how do we set those risks? In this, the person who was actually assembling the oxygen concentrator machine, his or her inputs were also taken, that what is the wall quality as per our user experience. So key risks if are associated with the person who is actually working, the data scientist or the person who is working, those are also to be noted. So that is why I need to select the right key stakeholders. So when we say key risks, the key stakeholders, so this should include anyone who will benefit for the product. So I would say the person who benefits and the person who is impacted. Benefited I will say, benefited or impacted persons. Benefit means ones who get the advantage or merits out of it, ones who is impacted, who gets some demerits out of it, maybe if it fails or so. For instance, if the person is to be, the person who is already busy on taking care of the queue at the system where the at the cash counter or so, if that person is asked to provide the data, he has to be given time. okay, an hour a day or maybe 15 minutes a day, please provide us this data in this form. So that person might think that he is impacted, his overall regular routine monotonous work is impacted. So if he is thinking it is like impacted, so that is to be taken care of. So benefited and impacted, both the key stakeholders are listed here. So team may feel that it needs to wait for the approval of someone who thinks that he or she is only the advisor. This person who is taking care of the cash could consider that, okay, this is only my advice that is required, but the team is considering this person as the approver. If this person provides the right data, that what is the major item that is sold between the peak hours in the evening, for instance between 7 to 8 p.m, what is the sale of the maybe child diaper, right, or small products like those. So if you are trying to study that, the person has to provide the data, though the data is fed in there, let me say there is no actual computer fed or so, so the person has to provide the data. So the person's approval is required. Yes, the person will happily provide this data each day in the evening or some, right. So the advisor and the approver are to be definitely clearly identified and definitely marked upon. Next comes the meeting with the sponsor. Meeting with the sponsor. Generally, the stakeholders who are selected now, the stakeholders, the person who are approver, they are definitely called for a meet with the sponsor. The advisor could also be called. Meeting the sponsor is important because what are the expectations of the person who is funding this project, who is providing the finance, what are his viewpoints, what are his thoughts, what does he expect and in which timeline. The questions are asked by the person who is versed with the project already. That interview happens in the front of the whole team. So this meeting is very important. So the questions, it is a kind of an interview only. It is interview. So the questions are open-ended. When I say open-ended questions, it should not be, do you wish to get the project completed within 3 months or not? Answer is yes or no. What is the time that you expect the project to be completed in? The person would answer 3 months or maybe within 2.5 months or between 3.5 months it should be completed. The open-ended questions should be there. It should not be answered yes or no, true or false or so. Open-ended questions. Then the small probing of the details or follow-up questions could also be asked by the interviewer. The interviewer also has to have good experience in drafting the questions properly and try to repeat. Sometimes repeating the questions means confirming what the person is saying. So this is repeating when you might have seen small interviews maybe in the TV programs or so. The interviewer repeats the answer or reframe the answer in a different way. This is to make sure that the audience clearly understand what the main person who is being interviewed has said. Okay, that answer is repeated time and again. Sometimes one time, sometimes two times it is repeated, so that it is very clear that what is wanted or what is told, right. So the small skills, the interview skills, that what business problem is the team is trying to solve. So what is the desired outcome of the product, what sources are available, so what are the industries you are trying to connect, what are the timelines, so who could provide the insights to the project, so who has the final decision making power here. So then regarding questions regarding the time, people, risk, resources, size and attributes of data, all these questions could be asked so that the people are clear that what they are going to do. Next step is develop the initial hypothesis. Develop the, I would say, first hypothesis. The hypothesis is a statement, as I said, we will make one statement, then our team can compare its answer with the outcome of the experiment. So it is the best to come up with a few primary hypotheses here. So these few primary hypotheses are answered. So we gather and assess the hypothesis from the stakeholders, that what are your hypotheses, this statement is made within this timeline, within this performance, would the things would come or not. Then we design the experiments. So the experiments are designed based upon this. The lecture on design of experiments will be taken in the forthcoming weeks, where we will learn that taking or doing the small number of experiments out of the big number of the sets of the experiments that could have been done. So this small set of experiments give the similar output, maybe with the 95% or 99% confidence level. So this is also important. This saves times and resources to a large extent. So this is how we define or develop the first hypothesis and design the experiments based upon them. Then we identify, using all of these, the potential resources. Resources here means the data sources. Identify potential data sources. When I say data sources, so consider the volume, the velocity, the veracity, the time of the data, the time span of the data in a way, the type of the data. So this again, the 5 weaves that we discussed, so those are all taken care of here. So we identify the data sources, we capture the aggregate data sources and review the raw data, right. So I'll jot down the points here. With 5 V's itself, we try to identify data sources, because this is the last step of the discovery phase. Now understanding who are the stakeholders, understanding the business domains, understanding the tools that we have, and formulating the problem and meeting with the sponsor. Now we will see what data sources are required and how do we capture the aggregate data sources. Capture the aggregate data sets or so. So then we review the raw data, evaluate the data structures and tools needed, and we set the scope of the data infrastructure. So unlike many traditional stage gate processes where the team can only advance when the next criteria is only met, so data analytics process can have a parallel retrieval or extraction of the data. So it is not once we only got this data then only the process will start. That is why how we prioritize the data based upon the secondary data itself. We start our training sets itself. So once the training is started, as and when we receive the other data within the next available time, we keep on input or keep on ingesting that data there as well. So and we try to have our algorithm run. These are the steps where we have just discovered the data. Now we will prepare the model, then build the model, try to get the results, communicate them and operationalize them. We will discuss that in the next lectures of this week. Thank you.